Hi guys, it's me, Jan Albert Siamper, and for today's video, we are going to have an experiment about projectile motion. But before that, there must be an understanding on how projectile motion comes to an existence. Projectile motion in sports includes throwing a ball or something that will result to a parabolic path. Inertia plays an important role in projectile motion because it explains why an object keeps moving without any source of propulsion. Also, let's not forget the importance of gravity, because gravity is the reason why soccer ball, volleyball, basketball, and other things return to the Earth's surface rather than moving continuously to the air. When there is force applied at the beginning of the trajectory, after which the only interference is gravity, it is called projectile motion. When watching a basketball game, do we tend to figure out how players shoot the ball at the perfect spot? Did they estimate how strong you throw the ball and what angle to put it in the basket? Or like watching a soccer game, do the players estimate how hard to kick the ball in order to arrive inside the net to goal? Well, these situations are some of the examples of a projectile motion. Projectile motion is a motion being experienced by a thing that is projected near the surface of the earth and moves along a curved path that is subjected by the acceleration of gravity. A projectile is any object that is given by an initial velocity and then follows a path determined entirely by the effects of gravitational acceleration and air resistance. We must know that the object is called projectile while its path is called trajectory. So, how do we solve projectile motion? There are some factors involving projectile motion, but in this experiment, it only uses range and the angle of release. Range is the horizontal maximum distance which a projectile can be propelled. The role of range in projectile motion is that it is a function of initial speed, just like the time of flight and maximum height, which is independent on the forces of gravity. There is no acceleration in this direction since gravity only acts vertically. Hence, this paper is written to guide and apply the concept of calculating range in a projectile motion experiment. This experiment will examine the range of a projectile subjected to different angles, specifically 15 degrees, 30 degrees, 45 degrees, 60 degrees, and 75 degrees. Through this conducted experiment, we'll be able to discern the relationship of range to the projectile motion of an object. For the objectives, at the end of this activity, the students will be able to find the relationship between the angle of release to the range and determine which angle has the shortest and longest range. In this experiment, the materials used are water hose, water, protractor, and a meter stick. Procedure number 1. Prepare the setup by placing a protractor on a flat surface, wall, or top of a chair. Procedure number 2. Measure the angle of release of the water hose at 15 degrees, 30 degrees, 45 degrees, 60 degrees, and 75 degrees. Third, launch the water and measure the distance from the protractor to the landing spot using the measuring tape. And lastly, record the range. So now that we're done with our procedure and we gathered enough data, let us now construct our table 1 for the results and discussion. Table 1 shows the different angle of release and corresponding range. For the relationship, the larger the angle indicates less horizontal velocity of the range. However, the smaller angle designates a greater horizontal velocity of the range. And now, let us proceed to the guide questions. Number 1. Which angle of release has the highest and lowest range reached? Explain. Number 2. Explain briefly why do we need to study projectile motion. For the generalization, the present analysis demonstrates the range of a projectile motion depending on its angle of launch. The water is launched in vertical and horizontal motion with different angle resulting to different ranges. The influence of the angle on the projectile motion may considerably alter its trajectory with respect to the parabolic shape expected in the absence of air due to the medium. The 45 angle manifests the largest range, however the corresponding below and above took the shortest range. Thus, the larger the angle of release, the shorter its corresponding range, and vice versa.